Okay, long division. We talked about the multiplication algorithm and why that process of kind of diagonal multiplying and then adding up the rows and stuff worked. Now we're going to do the same with division. We did a little bit a moment ago about kind of understanding division in our head, but now let's talk about that algorithm process. So I have a deck of cards I'm holding. I am pretending, deck of cards, that I have 1,125 instead of 52. And I'm trying to deal them out to 25 people. So how would I do that? I actually have a casino superpower that powers of 10, I can deal out that many automatically. So I could just take 1,000 cards out of my giant deck and give them to someone, or 100 cards and give them to someone, or 10 cards and give them to someone. So I'm going to start with the thousands. Does giving out 1,000 cards help me if I'm trying to deal out 1,125 cards to 25 people? No, I'm going to give away almost all my cards to one person. It's not going to be a fair deal. So we're skipping that one. Okay, now I'm going to look at the hundreds. I can deal out 100 cards at a time to people. Is that going to help me? Will I get all the way around? No, that would take at least 2,500 cards. So that's not helping me either. Now I'm going to deal out 10 cards at a time to people. Am I going to get around the circle that way? Yeah, with 25 people, that would take 25 times 10 is 250. So I'll get around at least once. So I will do that. 10 for you, 10 for you, 10 for you, 10 for you, around the whole circle of 25 people. So how many times can I get around the circle without running out of cards? I could just count 25 and then 50. So if you're used to this division algorithm, then what you're seeing is we're focusing just on the 112 and saying how many times does 25 go into 112? So how many quarters are in a $1.12? 4, right? Quarters. So I'm going to say I have 4. I get around the circle 4 times, but I'm not dealing out 1 at a time. I'm dealing out 10 at a time. So this is really 40. So I have 40 25s, which is 100 with that extra 0 at the end, right? This 0 goes with that 0. These zeros are the 4 times 25. So I've dealt out 1,000 cards. Now I have 125 left. I've tried dealing out 1,000 at a time. I've tried dealing out 100 at a time. I've tried dealing out 10 at a time. Now I'm going to deal out 1 at a time. And with the 125 cards left and 25 people at the table, how many times will I get around? 5. And if you are thinking about money again, how many quarters are in a $1.25? 5. So I will change colors. Say that I'll go around 5 times. 5 times 25 is 125. Oops, it's not a subtraction symbol. And I get done. And then when I combine these, 40 and 5 is 45. We don't normally write this 0, but we could. I want to do a simpler one now that you've seen that one I just did. And for now, let's just do 4 goes into 8,416. And I want to do this 2 different ways. So let me scoot it over. I'm going to pretend that I am somebody that knows my multiplication tables, and I'm going to pretend that I'm someone that doesn't. If I knew my multiplication table, then I would start by trying to deal 1,000 out at a time to 4 people. If I have 8,000 something cards and 4 people, I can go around twice and give out 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000. That's 8,000. If I didn't know my multiplication tables, then I can say, well, I'll go around once. And that would be 4,000 I'm getting rid of. And I can still deal out 1,000 at a time and go around another time, and that gets rid of another 4,000 cards from my hand. Now I'm to the hundreds place. I'm going to deal out 100 at a time to 4 different people. Okay, well, I will go around once, and that will deal out 400 cards. 100 to you, 100 to you, 100 to you, and 100 to you. Now I'm down to only 16 cards in my hand. If I don't know my multiplication tables, it would be the same thing. I go around once and I get rid of 400 cards. Now I'm looking at the tens place. I only have 16 cards in my hand, so I'm not going to get around a full circle of 4 people dealing out 10 at a time. So I have to just skip that one. If I didn't know my multiplication table, same thing. I would just have to kind of skip the 10 at a time. And then 1 at a time, how many times will I go around with 16 cards? 4 times 4 is 16, and I'm done. If I didn't know my multiplication tables, I could say I will deal out once. That gets me down to 12, and I would do once again, and I'm down to 8. Once again, I'm down to 4, and then once again, and I finally run out. And I can't write this down there because of my screen. And when I add all of that up, 2,104. So you don't actually have to know the multiplication tables to do long division. You can just write lots of numbers on top and collect them all at the end. And this might help you if you have kids at home. Yes. This one is much faster. Notice how little I write compared to the other one. So they teach you this one in school, at least they did a couple of decades ago, because this is the one that is efficient and fast. But the problem is if they don't tell you why it works, why is it that making tiles, which is what division is actually repeated, multiplying and subtracting?
There's one on the right, that's what they're doing right now.
They do this a little bit with smaller numbers in elementary school, showing you that you don't need to actually know 4 times 4 is 16 to do this. But the idea is to understand where the dealing out cards is, that as I'm dealing out cards to people, then I am multiplying the people by how many I deal out at a time. And then that amount is subtracted from what was in my hand because I've built it out. Do you want to do one more? 1620 divided by 12?
Yes.
Yes, okay. So I'm going to undo. Wait, another page, we don't. I'm just gonna undo that. No, it's not going over it. Okay, never mind that. Use a sticky note. No, that's the same one. This is the sticky note. There we go. No, that's not transparent. That is true. Okay, never mind. I have to erase. This will take a moment. Still that tool.
On the right side, at least your razor tool isn't already takes so long.
Yes.
My drawing app has to the.
Okay, so let's try the other one now. 12 goes into 1620. So I am holding a giant stack of 1,620 cards. Can I deal out 1,000 at a time to 12 people? No, I don't have 12,000 cards, so I'm not going to write anything above there. That's just a blank spot. Can I deal out 100 cards at a time with the hundreds column to 12 people? Yes. So if I deal out 100 cards at a time, then I will use up 1,200 cards. Since I had 1620 and I used up 1,200, I have 420 left. Maybe some other number should go up there because I've made a mistake with my multiplication. Can I do another 100 cards at a time with only 420? No, I'm not going to go all the way around to my 12 friends. So let's deal out 10 cards at a time. Can I go all the way around with 10 cards dealing out for 12 people with 420? Sure, because I have more than 120 cards, so I can get at least once. So 120, 280. No, 120, 240, 360. That's all I'm going to get because it'll be 480. So 3. So do some borrowing. And I have 60 cards left when I'm done. So one at a time, how many cards do people get? If I'm dealing out cards one at a time to 12 people, you'll each get 1, you'll each get 2, you'll each get 3. Five times 12 is 60. And we're done. And if your mental multiplication tables aren't speedy, then you could do that again. Saying, well, we'll go once here because that's easy. And maybe I'll go once for 120. And maybe I'll pick a 2 this time for 240. And then I can't do 100 anymore. So how many ones? I don't know. Maybe I'm doing 2 because 2 times 12 is 24. And that gets me down to 48. And then I would do a 4 because I remember 4 times 12 is 48 or whatever. You can break this apart smaller as long as when you're done, you add it all up. The 1, the 3 in the tens column, the 6. Whoops, I did it wrong, didn't I? Yes, I did it wrong. I'm thinking about what I'm trying to say instead of what's true. So 60 minus 24, what should I have written?
$42.
36, yes, so then we'd have a 3 here for 36. No, go away from here. So 315. Okay, so I get the same answer.